Well, good old Norman window question. And it always looks the same. You always have a semicircle. And so we're going to cut this guy. And we're going to draw ourselves a rectangle, hopefully. Pretty much. I'm going to make this grow enough. There we go. And I'm going to cut this here. Yay, I have myself a standard Norman window question picture now. Yay. Okay, now what I want to do is I want to either minimize the perimeter or maximize the area. That's the way these questions go. And right here is going to be the radius if it refers to some sort of a radius. And right here will be the height. Yeah, there we go. So the perimeter is going to be 45 feet, and it's going to be composed as the top half plus everything else. So it's all in terms of h and r. So the semicircle, so a whole circle would be circumference is 2 pi r, so it's just pi r for the top piece. This piece is the pi r piece, and then the rest of it you have 2h, so you have the two sides, those two sides, and then you have just 2r for the bottom. Okay? There you go. Now what? We need to solve for h. I mean, you could solve for r, I guess, but that would be a pain. We need to say what the area is. We're not going to solve for h right now. We will be doing that in a second. The area is, again, composed of the top half plus the bottom half. So the bottom half is 2rh, that's the bottom half. And then the top half is pi r squared over 2. Okay, so this is the piece we need to maximize. So right, we have two options. We can either solve this expression up here, we can either solve for r and plug it in that way, or solve for h and plug it in that way. But it's just easier to solve for h, because there's only one little h hanging out. It just looks easier. It's not really that much easier, but it's kind of easier. So we're going to solve for h. Alright, so we go ahead and put everything that's not h on the other side, and then divide by 2. There, we solved for h. Now we're going to plug that into area. Nice, the 2's cancel out. Plus pi r squared over 2. Right, so now area is only in terms of radius. Why is that? Well, because we had a fixed perimeter. So if you imagine a loop of string or something that's 45, whatever units, 45 feet, then as you keep changing height, radius will change, or as you keep changing radius, height will change, but you can't change both of them independently because you already know what the perimeter is. Okay? Alright. And you know that if you have 45 feet, you could end up with a semicircle. I mean, if h is 0, you'll end up with a semicircle. But if r is 0, you'll just end up with no area at all. So that's even worse. A semicircular window, at least you could see through it. Okay, so we need both r and h to be positive. So just things to know. Find the dimensions of the window so the greatest amount of light is admitted. Okay, so I'm going to put my area over here. 45r minus pi r squared minus 2r squared plus pi r squared over 2. So we minus or plus? Plus pi r squared. Wow, but this one's a minus. So when you combine them, you're going to get minus pi r squared over 2. So let's rewrite that. And we may as well get rid of the extra term while we can. You can combine that minus pi over 2 and that minus 2 together, but I'm just not going to bother. I'll probably have to do it eventually anyway. I'm going to take the derivative of that with respect to r. So the 2 is going to come out front, we need a pi r, right? So it's going to be 2 pi r over 2, so the 2's will cancel. Then this thing will become minus 4r. Alrighty. Right, back to what we were doing. So I'm going to set this guy equal to 0 and solve for r. So I'm going to put everything with an r on the other side. Then I'm going to factor. I'm making a big mess of the page, aren't I? Is aren't actually a word? Anyway, so there I have r. And now I'm going to find out what it is numerically. 45 divided by pi plus 4. About 6.3. A little bit bigger than 2 pi. Well, there's r, but does it say find the radius, or does it say find the height, the dimensions, does it find the area? So we got to go back and read the question. Okay, we took all this information. Find the dimensions of the window. So we already have r, we just need to find d. It could say find the greatest area, but it didn't. It just said find the dimensions. So we've got r. So we have 6.3, what was it, feet? Yeah, right, okay. It's a pretty big window. Okay, h, we already solved for h in terms of r. So we just go back to that. H is equal to 45 minus pi r minus 2 r. I can't control my computer. There we go. And then divided by what? Alright, so let's figure this out. We have luckily only one instance of a pi, minus 3.14159 times 6.3. Yeah, I gotta get another computer. I bet there's an app that has, I probably actually have a pi in here, I just don't know where it is. Oops, I did not put a decimal in here. Put a decimal in there. Now, is it right? 45 minus pi times 6.3 minus 2 times 6.3 equals. Then I'm going to divide by 2. I got 6.3. That does not even sound right. Well, that's what my answer key says. So, the next thing I do is I check to see, so 6.3 feet. Okay, so now let's check with the answer key to see if, I'm sorry, let's check with the question, right, to see if the perimeter is 45 feet. This is a sanity check, and it doesn't need to be done if you're running out of time on an exam. I've already been informed by many of your classmates that they will be very unhappy if there is a Norman window on the exam. I can't guarantee one way or the other, but I will take that into consideration. I will try not to put too many difficult questions on the same exam. Sanity check, perimeter equals, is it equal to 45? But it should equal pi times 6.3 plus 2 times 6.3 plus 2 times 6.3. Everything's times 6.3. So let's try doing this. 6.3 times pi plus 4. Yay, I'm happy. That's good enough. Okay, sanity check works. And I guess that's the end of this question.